Hello, first graders. Welcome to part 2 in our lesson for today, Be a Scientist Notebook. Please open page 20. All right, inquiry activity, sound waves. We're still talking about waves in sound wave and that we cannot see it all the time, but we can hear it. So let's do this one. How can sound waves change? Make a prediction. Prediction means you're guessing. You think this will happen. You could be right or wrong, but that's the whole idea of prediction. You don't have to be always right. But for example, make a prediction of that. How are sounds different? Remember when we heard the elephant video and we know that they make different sounds? So how the sounds were different? Yes, sounds can be loud or soft. Very good. So we can write down here. This is sounds can be loud or soft, right? So that's how sounds can be different. All right. If you need more time, you can always pause the video to write down this one. Now clear, and let's go for the second part. All right. In order to make this activity, we need to have safety goggles, plastic cups or balls with water, and tuning fork. Okay, we're gonna see how this investigation take place, and we're gonna watch a video because we need to answer page 21 and 22. So let's just take a look at the question first. We're gonna record your data. You're gonna record the information you're gonna observe or you watch. Use the table to write what you see and what you heard. So you're gonna write here what you saw and what you heard when we watch the video. And then we're gonna answer this. What made the sound in your activity? Again, when we play the video, but I just want you to know what question you have and what you need to know in order to answer your question. All right, over here, follow the same procedures, but strike the tuning fork harder than till what happened. This is also, we're gonna see it in a video and you will be able to answer this part as well. All right, so let's watch our video.
Hey you guys, Mr. Reeves here. So I want to do a demonstration of sound waves for you. And to do that, I've got these devices. They're called tuning forks. Each one produces a different frequency. Can you predict which one has the higher frequency? I don't know. Think about it. All right, let's try the little one first. So I'm going to bang it on the table, listen to the sound. Oh, yeah, that hurts my ears from here. All right, and then let's try the bigger one. This one's longer. So what did you predict? Yeah, this one's the lower frequency. Okay, the longer it is, the lower the frequency. Remember, frequency is vibrations or pitch, right? Okay, you can do something really cool with these. I'm going to take the bigger one. I've got a little bowl of water here. This is going to get a little crazy. I'm going to take this and I'm going to hit it hard on the table. And I'm going to put it in the water. Watch. Oh! You see the water shoot all over the place? I'm going to do it one more time. You can't see the forks moving, but when you put it in the water, you could clearly see the energy and the speed at which those forks are moving when it has that sound. So let's try the little one just for fun. Okay, here's a little one. Probably not going to move as much. Let's try it again. Whoa, that one worked good too. All right, hope you guys enjoy the video. Take care.
All right, so I'm
try
gonna
the bigger one.
More time.
Produces. Hey, you guys, Mr. Reeves here.
And
so I want to do a demonstration of.
Pay attention. to the sound and what you see. Also, the sound was harder or softer or louder. Also, that ripples or that water waves, was it bigger or larger or smaller? So, because this is all, we need this observation to answer our questions.
Sound waves for you. And to do that, I've got these devices. They're called tuning forks. Each one produces a different frequency. Can you predict which one has the higher frequency? I don't know. Think about it. All right, let's try the little one first. So I'm going to bang it on the table and listen to the sound. Ooh, yeah, that hurts my ears from here. All right, and then let's try the bigger one. This one's longer. So what did you predict? Yeah, this one's the lower frequency. Okay, the longer it is, the lower the frequency. Remember, frequency is vibrations or pitch, right? Okay, you can do something really cool with these. I'm going to take the bigger one. I've got a little bowl of water here. It's going to get a little crazy. I'm going to take this and I'm going to hit it hard on the table. And I'm going to put it in the water. Watch. Oh, do you see the water shoot all over the place? I'm going to do it one more time. You can't see the forks moving, but when you put it in the water, you could clearly see the energy and the speed at which those forks are moving when it has that sound. So let's try the little one just for fun. Okay, here's a little one. Probably not going to move as much. Let's try it again. Whoa, that one worked good too. All right, hope you guys enjoyed the video. Take care.
All right. So let's go back to our pages and try to, this is what you need to do, the experiment that we just watched on a video, because I know it's not always, tuning fork is not always available, but it's really easy. So now we need to put down the information, what you saw and what you heard. All right, remember, when we hit the tuning fork first, what happened? What did you see when they hit it and then put it in water, the bowl or the cup if you watch another video with the cup? So what happened to that water? Okay, so we are writing here what I saw. Very good. I saw waves or ripples in the water. All right. So this is what we saw. Okay, what did we hear? All right. We heard a humming sound, right? So you say, I heard the humming sound. So in this experiment or this video, we were able to see what happened when we hit the fork and we put it in water, the bowl of water, or when I just first started and make that sharp sound or that loud humming. All right, remember that we have two different tuning forks, but the idea is the way you hit it. Did you hit it hard or you hit it soft, and what happened? All right, so let's clear the drawing and move to communicate. Second question or second part on page 21. What made the sound in this activity? So why we heard the sound? Because the movement of the tuning fork, right? When we hit it, what happened? The movement or the vibration of the tuning fork made the sound. So we need to write this down. All right. So we're going to say the movement of the tuning fork made the sound, or the vibration of the tuning fork made the sound. So this is our answer for second question, or second part of page 21. All right. Okay, I'm gonna clear, and as I told you, if I move fast, you can just pause the video, take your time till you write your answer, and then continue listening to the rest of the video. So I'm gonna clear this, close that, and go for next page, page 22. All right, now we need to test our experiments, or let's find out if we have the right answer. So follow the same procedures, but strike the tuning fork harder, and that's what we watch in the video, and predict or tell us what happened. So you can always play the video again and try to get this answer. But what happened when we hit it harder? First of all, what did you hear? Lower sound or higher sound? Of course, the sound was louder. And the ripples or the waves in the water was larger as well. So the waves were larger and the sound was louder when we hit it hard. So we need to put this down. So what happened to the sound? As we ask here, the sound was louder. Oops. And ripples or the waves were larger, right? Okay, so this is the part. As I said, you can always play the video again and pay attention to this part. When you strike it, when you strike the tuning fork really hard or harder than before, the sound was louder, and the ripples or the waves in the water were also larger. Okay. Here. Let's go for number 4, or the second part of page 22. Now draw a conclusion. Draw a conclusion means say, okay, what did I understand, or the main idea now that I say, what did I learn from what I did? So draw the conclusion. Oh, how are the sounds and the waves related? So now I have to find out links or connection that, okay, now I know this experiment, I learned that what's related between the relation between the sounds and the waves. So I can say that the softer the sounds made, the smaller the waves, right? And when I made louder sounds, when I hit the fork harder and I made louder sounds, I saw larger waves or larger ripples. So this is the conclusion. If I hit it soft, the sound will be softer, and of course the waves in the water ball, it's lower or it's smaller. And then when I hit it hard, I heard louder sounds and it made larger waves. So let's write this down. Okay. So softer sounds made bigger or smaller waves. Very good. Softer, smaller, smaller waves, right? And then the louder sound. Louder sound made larger. Very good. Larger waves. So now this is what I understand from this experiment, that yes, when I hit the tuning fork hard, I made louder sounds and I saw larger waves in my water, or the water ball, or the cup, if you saw another video's cup. And when I hit the fork softer, of course, it made softer sounds, and then it made smaller waves. All right. Okay, so that's it for today. We learned about the tuning fork, and then I watched and witnessed what happened, and I heard what happened from her hitting the tuning fork hard or soft, and I saw the water ripples or waves was larger or smaller. All right, that's it for today, first graders. Thank you. Bye-bye.